So the next talk today will be by our keynote speaker, Gustavo Alonso. Gustavo doesn't need an introduction to many in the community, but I will still do it for those who don't know him in detail. So Gustavo is very well known for hardware, but just to give a little bit of history to it, the database systems community has been defined by the hardware that databases run on. We were originally on tapes, then we went to disks, SSDs, distributed systems, cloud, and so on. And if you've been attending the sessions in this conference, you'd know that we are now in the midst of yet another revolution in the hardware on which our systems run, with distributed memory hardware, which is now moving towards GPUs for database query processing and so on, FPGAs. So there's a whole lot of work in this area. So we are in the midst of a new revolution in hardware. And it is very appropriate today that we have one of the foremost experts in this area, Gustavo, giving us the keynote today. So Gustavo is originally from Spain. He did his PhD in UCSB with Divi Agarwal and Amar, who are here. And in 1998, he joined ETH Zurich. As one of his students apparently told him, 1998 is a long way back for today's students. And he said, wow, you were a professor before the internet. So of course that raises the question, if he's so old, which he isn't, what about Amar, who is here? So I think that dates Amar back to the pharaonic era in Egypt. Okay, so coming back to Gustavo, sorry. Yeah, he is now professor in ETH Zurich, and he also heads the Institute for Computing Platforms and the AMD ETH HACC initiative. As I already said, he's been a pioneer in hardware. He's worked on distributed databases, transaction processing at IBM Almaden before joining ETH Zurich, and subsequently has worked on hardware acceleration, FPGA processing, hardware, software, co-design, and multiple other areas. He's not just a database person. His influence extends to multiple communities. He has had publications in not only SIGMOD VLDB, where they've had a lot of impact, but also SOSP, OSDI, Eurosys, ASPLOS. And what is impressive is that he has won Test of Time or similar awards in 4 different communities. So that is really amazing. Of course, he's received numerous recognitions. He has been ACM Fellow, IEEE Fellow, Distinguished Alumnus of UCSB, recipient of Eurosys Lifetime Award, and so forth. So I'd like to welcome Gustavo, who will talk to us about a new golden era for data management. Thank you, Gustavo.
Okay, is this on now? The microphone? Excellent, very good. So my slides are up. I'm here. First of all, namaste. Thank you very much for the invitation. Thank you very much, everybody, for being here. This has been an absolutely fantastic conference. This is an impressive venue, and it's going to be a very difficult act to follow, not only because of the dancing yesterday, I'll come back to dancing in a moment, but also because of all the impressive keynotes and talks and ideas that we have been discussing during the conference. So I have the disadvantage that I'm the last keynote, and after a long list of talks and keynotes that have been absolutely outstanding. But I have the advantage that I don't have to give my keynote. I can just point out to what cleverer people than me have been saying all week, right? I mean, I don't have to do much. But anyway, I'm going to try anyway. So in case you have missed a keynote or some of the other things that I'm going to mention, let me just repeat them here as an introduction to what is going to be the topic of my talk, my presentation. First, this is going to be, for those of you who were here, Jagadish just received the highly deserved Innovations Award, and he said that when he gave his keynote at SIGMOD, right, already many years ago, he gave a manifesto. So mine is going to be of a manifesto. It's probably going to be a bit more aggressive and provocative than what he did at his time, but for those of you who know me, you're used to this. Everybody else, please don't be offended. This is just food for thought. The other thing that I'm going to try to address is not only research, but also I want to address the community, because I think we are a bit of on a tipping point. We're asking ourselves many questions about how to continue, what are we going to do with AI, what is our role with LLMs, but also about how do we act as a community, how do we exchange research, what is the meaning of research as we move forward, and I will try to touch on this as well. Let me nevertheless, as I said, use things that have been said in the last days. Yesterday in the panel about funding, Professor Gupta from University of California, San Diego, said something that immediately resonated with me. And I had not heard it formulated in that way, but I found it very powerful. He actually said, databases, data management, whatever you want to call what we're doing, is a subject matter. What he meant by this is that we are part of the core knowledge of computer science, computer engineering, right? Today, the notion of transactions is widely accepted. It's considered the gold standard for correctness in concurrency control. Many of the ideas that we have implemented over the years, data structures, query optimization, schema, a lot of the data structures and algorithms that we have developed are considered a core part of computer science. The question is that how do we move forward? We have actually created this subject matter. But he not only said this, he said the problem is that if you don't innovate, if you don't actually try to do new things, what is going to happen is that we are going to become just an optimization mechanism for LLMs. And I think that will be a very bad idea. We need to continue being a subject matter. And the question is, how are we going to get there? And I'm going to give you my personal opinion of how to do this. Now, we have heard on the two past keynotes were absolutely amazing, and I don't know whether I'm going to be at the same level. This is why instead of trying to be profound, I'm just going to be controversial, which is much easier. So in the first keynote, we show all the things that you can actually do with machine learning. What somebody who has a huge amount of expertise in a particular topic, what they can achieve using machine learning. And this actually affects the community, affects research, the definition of what is research, what is a contribution. In the second keynote yesterday, Tova Milo told us all the great things that as a community, as engineers in data, we can actually do for machine learning. And she's perfectly right. We have a lot to contribute. And Jagadish has also mentioned this in his presentation, right? So I completely agree. However, I do see a danger in there. And the danger is that, as I told you, that in the panel yesterday was mentioned, if what we do is devote our efforts to try to contribute things to LLMs, we are going to become the optimizers of LLMs. We are not going to be a subject matter. We are just going to be working deep in the plumbing of LLMs, helping LLMs to become more efficient, helping them to become better, but we really would not be a core matter in computer science. And this is what I think that we need to address and we need to change as we move forward. So I'm going to start by giving you my personal perspective on the database community. I'm going to take advantage that I'm a little bit of an outsider. As it was mentioned in the introduction, you're calling me a hardware people. This is always interesting because here I'm a hardware people. When I go to hardware conference, they call me a database person. When I go to an operating system conference, they call me I'm a network person. When I go to a network, so I'm nobody nowhere, right? I mean, so that because I'm definitely not a hardware person, right? I use hardware, but I'm not a hardware person. Anyway, so with this role of outsider that all these communities are attaching to me, I'm just going to give you, again, a very personal perspective on the database community. So one of the things that we have been hearing, right, I mean, not only in this conference, for the last years, right, is that we are doomed. Machine learning is here, query processing, transactions, creation of indexes, everything is going to replace with AI, and we are toast, right? I mean, so we can continue working on doing vector search, but that is our future, and there is nothing else. Now, I think this is actually wrong. This is not what is happening. However, I want to spend a little bit of time. As I said, my goal is not to be deep, it's to be controversial, which is more fun and it's easier. I want to give you a very, very personal perspective on the database community. So the first one is what is good about this community. And this is just to sort of make sure that everybody is relaxed and feels good and things like this, and then I'll hit you. So the first one is the success. It is undeniable that in research, in industry, and in academia, our community databases is extremely successful. For the younger ones, you'll hear about LLMs. LLMs are still losing a lot of money, right? There was a financial newspaper that called LLMs a financial pit with a website. And the thing that is making money for many cloud providers, for many hyperscalers, is still data analytics. Data analytics is still several $100 billion industry, right? So we are extremely successful, they're extremely used, we are very important in society in general and for many applications. In research, as I said, we are a core subject in computer science, right? I mean, we are a topic that any computer scientist needs to know. And in academia as well, we are a community that has been growing over the years. We have already several generations of people doing databases. We have great faculty. We have people in many companies, right? I mean, taking positions of responsibility. So it's incredibly successful. And in terms of people, honestly, since I know several communities, I go to conferences in different areas, this is definitely the nicest communities with the best people that I know. Not only in terms of diversity, in terms of inclusion, in terms of friendliness, in the way we actually interact with each other, and so forth. There are a few exceptions, I'm not going to mention them, but in principle, you're all very nice, right? And that's good, okay? So I just hope that everybody feels now relaxed and a little bit awake. Now comes the bad part. So what is the bad part? Is that databases are incredibly, database community as a whole, right? I mean, this, of course, when you're talking about a large community like ours, it's very difficult to talk about individuals. I'm talking about the community as a whole. It is incredibly insular and isolated, right? It is amazing how much the database community, and I have been here for now more than 30 years, how much we actually ignore what's going on in the rest of the world. And also very interesting, in spite of the fact that we are a core subject in computer science, we are constantly following the latest gimmick, right? So the latest fashion, we jump into it like everything else that we are doing doesn't matter, right? And we do it over and over and over and over and over and over again, right? I'll come back to this. And part of the problem, and this is the ugly part, is that, and now some of you will be surprised, some will disagree with this, is that we have too much influence for the short-term interest on companies. This is a side effect of having this huge industrial success, right? We have a lot of the community, and it's fantastic. As a community also, we have a huge presence from industry that, again, for the young people and those who don't go to other communities or you're not familiar with other communities, this is actually very unique. Here we have, in the past it was IBM, Oracle, today is Microsoft, Amazon, Snowflake, Philip, former student from the systems group, very proud of him, just gave a great presentation about Snowflake and all this innovation, right? So you have this interaction of research and academia, right, that is very, very, very fruitful. It's very, very helpful in practice. However, that actually has a side effect, is that we tend to work as a community too much on problems that are the problems that the companies have today. And I don't think that's what academia has to do. Academia needs to look 5, 10 years ahead. Let companies solve the problems of today. We need to sort of move forward and look at the problems of tomorrow, okay? And because we are focused on the problems of today, it is actually very difficult to find groundbreaking research in our conferences. It's really, really very difficult. These papers are very difficult to get through. And I know I see some skeptical faces here. Carsten is starting to complain, right? I mean, again, go and read the proceedings of other conferences, and you will actually find not all of the papers, but you will find enough crazy ideas, right, that are being proposed that are understood as what they are, crazy ideas that might actually be able to move the field. And these in databases, in conferences like SIGMOD and BLDB, is actually very difficult. We have created other venues for this. There is CIDR, ICD has the depth. In other conferences, we have tried to do this vision. But on the large venues, SIGMOD and BLDB, there is very little of this, right? And then this is a personal pet peeve of mine that I'm going to just take advantage that I'm on the stage to complain about this, is that actually nobody cites original material, which means that we are forgetting our history, and periodically we have papers that are completely reinventing things that have been done already many times, right? So Phil Bernstein gave a fantastic keynote last year pointing out that a lot of the work that is being done on transactions still today was done already 30, 20 years ago, right? And we keep revisiting over and over again. But anyway, that's a different story. So now we are in India, fantastic country. We just yesterday we learned about how many cultures are here, and there is a particular culture that I find very, very interesting. How many of you have heard about the Northern Sentinel Island? Okay, so a few of you, right? So this is an island, for those of you who don't know, it belongs to India, it's in the Andaman Sea. And there is a tribe there of people who actually refuse contact with the rest of the world. There are, and again, this is not politically correct, but from the Western perspective, they are very primitive. They are hunter-gatherers, right? I mean, they still work with bows and arrows. They hunt and they fish, and they actually refuse any contact with anybody else, to the point that it's actually forbidden to go to that island because there is the danger of contamination and illnesses and things like this, but also because they have actually killed several people who have gone into that island, right? So it's not something that you want to play with. So this was an article, right, I mean, that explains a little bit the fascination that everybody feels for the people in this island, right? I mean, and I like this sentence a lot. The North Sentinel Island resists not only colonization, but explanation. It doesn't want gods or your GoPros, and that makes it perhaps the last truly sovereign space on Earth, untouched, unrecorded, and uninterested in us. This is very profound, and you only need to do a slight change, right? And this is us, right? So the database research resists not only colonization, but explanation. It doesn't want advances in IT, and that makes it perhaps the last truly sovereign research, untouched, unrecorded, and uninterested in anything by itself. Now, Mohan is already saying, you know, what I'm talking about, right? I mean, IBM has been doing this for the last 30 years already, right? I'm going to demonstrate you, and this is a mathematical proof, right? I mean, of why this is the case. And again, I'm going to take advantage of this fantastic conference because it has been very inspirational. And this is the great research done in databases. The way we operate as a community is like a Bollywood dance, okay? So we are a community, as I told you, we are fantastic, it's great, we are all good looking. So we are like in this picture, right? I mean, we are a great ensemble. And what happens is that all of a sudden there is a guru that goes and says XML. And then everybody goes XML, 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 right? It's fantastic, right? It's great. You see, you agree. But then, you know, a year later, somebody comes and says, learn indexes. And everybody goes, learn indexes, learn indexes, learn indexes. And we do this all the time. Now we're with vector search and graphs and, so again, this is what happens. Now, why am I saying that we are like these guys in this island, right? Is because we are a community that is big enough, we like ourselves very much, and then we get into this collective dance that is absolutely fantastic and great fun, but the rest of the world doesn't give a damn about us, right? So, now, data management is, I find it is too gregarious, too incremental, driven not by technology, but by marketing. This is something that we really need to address. And I think really that academic research should look farther into in the future than actually than companies, right? And this is something that collectively I think we need to change. Now, let me turn now, since at the end of the day this is a technical conference, let me talk a little bit into something technical. So why is the hardware era? So for those of you who actually read something outside of SIGMOD papers, the title of my talk is a rip-off of the Turing Award talk of Patterson and Hennessy, where they were talking about the golden era in computer architecture. So actually, I took that idea and called it my talk, the golden era in data engineering or in data management, because this is, I think, where we are. And what is surprising, as I told you before, because we are like these guys in this island trying to ignore the rest of the world, is that I think collectively, and again, collectively, there are some people who are very much into this, but collectively, we are ignoring one of the biggest changes in IT history. And this is not LLMs. And let me explain you why. So, I claim that most of the designs that we have in databases, and this was definitely true until a few years ago, now it's changing a little bit with the cloud providers, but a lot of the designs that we have are reactive. We don't influence the hardware, we don't tell computer architects what we need, we just wait until they throw something at us, and we start trying to sort of figure out how to use it. And now, sorry for the snowflake people, because now this goes into your direction. So how do we end up with native, cloud-native databases? Well, when the cloud started, and as he was saying in the introduction, and before the internet, right? I mean, and definitely before the cloud. When the cloud started, there were two models of how to build the cloud. One of them was the web search, Google type of model, and there was a web shop, and this was Amazon type of cloud, right? And they were all predicated on something that anybody in databases immediately recognizes, right? So you get a query, goes to some sort of front end that parses this query, splits the query, sends it to a bunch of compute nodes. These compute nodes do a local search. No, they don't do a local search. No, local search. And then produce a result. And then you send the results to the front end, and this comes back, right? And then people very quickly realize in the cloud that this doesn't work. You can actually not do this at very large scales. So what you do is you take the storage, you put it into a storage node. This is a disaggregated storage, and Philip has been talking a little bit about this and what problems this creates for databases. Eventually, people realize, you don't want to really have a collection of machines with disks. What you want to do is you want to provide a unified layer. This is what is called a storage layer in the cloud. And then you actually build, again, your web shop or your search engine, right? I mean, coming up with an architecture that looks like this in a very, very schematic way, okay? Now, Philip already pointed out this morning, right? Elasticity and the characteristics of the cloud really do not fit the traditional architecture of databases. It really didn't work. This is what actually led to the creation of companies like Snowflake, right? Try to build something for this type of architectures. Now, the reason why I'm showing this picture is that you might actually say, well, of course, we are important. We are these databases there, right? I mean, however, this is actually at the absolute bottom of the hierarchy. And this actually leads to what it was also said in the panel yesterday, right? Is that the action is moving up to the upper layers, right? This is where the attention is, right? And if you remain just as something that is really deep into the bottom of the architecture, right, you actually become irrelevant. What is worse, and now I'm going to talk a little bit more into the practical implications of this, what is worse is that this architecture actually is very bad. I was giving a talk a few years ago, and I said one of the problems that we have is the cloud, and everybody started laughing. I think now there is proof that one of the problems that we have is the cloud. The cloud did this because for a cloud provider, this architecture makes sense. They can actually share the architecture, they can share the machines, they can actually run many virtual machines. There is almost no application for which this architecture makes sense. And because of the performance penalties that this architecture induces, we end up with something very complicated. You need to have load balancers, you need to have caches, this is where key value stores start appearing. You need to start using compute nodes as memory nodes, because going to S3 or to storage is actually very slow, and all those other things. So this actually becomes very, very expensive. So what was our reaction? Our reaction was to take what you see on the left is taken from an Oracle manual, is the architecture of a traditional, conventional database engine, the one that we have been teaching to our students for a long time. And then we took it apart and put it back together for the cloud. And this morning, we heard this presentation from Snowflake that actually translated these ideas into the cloud. Now, it's not exactly the same thing, but the concepts are very similar. Of course, you need to figure out how to actually work in this highly distributed environment. You need to figure out how to deal with virtual machines. You need to figure out that there is network all over the place. And the unit of data exchanges, right, is not like a page that you have in a normal computer, but now you have much larger units, and actually that changes the architecture. But the underlying principles, the core subject that I mentioned at the beginning, do not really change, right? This is what I mean that instead of actually going and telling the cloud people, please get your act together and give us something that we can work with, we actually go and try to adapt what we do to these architectures. This is why, for instance, in Amazon, there is something called RDS. RDS is a whole stack specialized to actually run conventional database engines, because if you try to put them on a conventional virtual machine, you have a problem. In 2018, Eric Brewer gave a keynote in this conference. He was talking about Kubernetes, and he actually spent quite a bit of time explaining how disastrous were databases running in containers and running in virtual machines, because in essence, they have not been built. Traditional architectures have never been built for doing anything like this. Now, what is the problem with the cloud? What is the problem of just taking what we were doing before in a single system and moving it to the cloud? There is something called the data center tax. How many of you have heard about the data center tax? Clearly not enough. So please don't read database papers. Go and read something else. Educate yourselves. This is really a fundamental paper published a few years ago, 2015, in ISCA by Google, where they actually explain everything that was on racks, microprocessors, everything that was wrong on the architecture at the time from the perspective of a cloud provider. That paper is fundamental to understand how hardware has been evolving in the last 15 years, because almost everything that is described on that paper has now been implemented, and all the way from the architecture of processor instructions, architecture of machines, rack-level architecture, and so forth. And one of the things that they mention is this data center tax. What is this data center tax? The data center tax says that at the time, they were spending more than 25% of the CPU cycles on simply running the infrastructure. These are things like data compression, allocation, hashing, protobuf, and RPC. This is related to remote procedure calls, memory copies, and things like this. Now, if your business model is to rent computers, and you need to have almost 30% of the computers that you want to rent are actually used to be able to run the infrastructure, you clearly have a problem. But it actually tells you how much overhead, what is the incredible overhead that is behind the architecture that we have in the cloud. This is why the cloud is, for an individual application, is actually very expensive. Now, some of you might be telling me, Gustavo, we don't care. We are not architects. We are not running the cloud. We are actually database people. We are very happy to run our databases. Now, I'm going to go back to this later on. Now we have something that I call lakehouses. And lakehouses are actually really a reflection of what is the cloud architecture. So this is actually taken from a paper that John has done, that is sitting somewhere in the crowd, right? I mean, raise your hand so people can hit you later on. He actually presented this at Damon, where he actually took DuckDB, and then he used DuckDB to do the lakehouse thing, actually reading parquets. In this case, it was just reading parquets from the memory of the same computer where DuckDB was. We're not even including the network overhead. And this was done for TPC-8, TPC-DS, and ClickBench, right? And just to run a short story short, right, 50% of the CPU cycles go into parquet decoding, right? So this is not even query processing. You're just dealing with parquet decoding, right? If you were there for Raghu's keynote or presentation, right, I mean, on Sunday, right, on the formats workshop, he actually said the same thing. He said, well, you are observing that in the lakehouse, a huge amount of the cycles, most of the overhead goes on running the infrastructure and not running the queries, right? So this is why we have to be careful. If the only thing that we do is actually improving our queries a little bit, but the biggest bottleneck is somewhere else, then our improvements, our work becomes highly relevant, because actually the load is in other places. Now, what is the rest of the world doing about this that we are not doing? They're actually moving to hardware. Here I decided to keep this story short, but I have an entire talk, and in fact, almost an entire course on the hardware evolution and all those sort of things, right? I mean, at ETH. But what cloud providers have done, because they don't want to spend 30% of the CPU cycles running infrastructure, everything that matters has actually moved to hardware. They have smart NICs, they have active storage, they are coming up with new CPU architectures, right? If you think that the world is still x86, think again. A lot of the processors in the cloud are becoming ARM processors, smaller and smaller cores. CPU is actually losing its weight, right? I mean, I'll come back to this in a second. There are new instruction sets, new architectures that are coming up due to the geopolitical problems that we are all aware of and that we have suffered very much with the visas here. For instance, in Europe, there is a very, very strong move to come up with our own processors. Same way has happened here in Asia, right? People are now building RISC-V architectures where you can actually go and define your own instruction set. And for instance, with Edith Zeklar from Oracle, who has been a long-term collaborator with our systems group, we are actually thinking of what instructions we can actually put in a processor that will actually be very helpful to actually run data analytics. And this is something that you can actually do today. 20 years ago, this was impossible. You were not going to convince Intel to put any instruction in there. But now you can actually do it, and there is enough people creating these processors to actually do it. Now the question is, if the entire world, except us, is actually building new hardware, the questions that we need to ask ourselves is first, how much of this hardware is helping data processing? And second, how much are we influencing this hardware? What do we have to say to the computer architects and the hardware vendors and the people who are building all this specialized hardware and tell them, if you put in there, our several $100 billion industry will become much better or more efficient or will become faster or will become bigger. And this is what we are not doing. So let me now do a little bit of an exercise with a question and a bit of a quiz. So how many of you have heard about the NVIDIA NVL72? Not enough people, clearly. So this is actually a very interesting machine by NVIDIA. Is what, since I'm before the internet, right, in my old times, we will call this a supercomputer, right? So this actually has 72 GPUs. This is what is called 72. If my memory does not fail me, this machine, which is a rack-level machine, has 30 terabytes of memory. 13 of these terabytes are high-bandwidth memory. Okay? What is very interesting about this is the connections. There are 9 NVLink switches. NVLink gives you 1 terabyte per second bandwidth, right? Much more than we are typically used, and we are constantly fighting PCI, right? There are NICs, network interface cards, and smart NICs all over the place, and things like this, right? And this has been around for only a short time. Now we are already in the NVL 144, which is twice as big. If you don't want the NVL 144, there is the NVL 72 plus the LPX, which is a very interesting architecture where you have here the GPUs, and here you have another rack that is full of specialized processors. These are Grok processors. This is a company that was acquired by NVIDIA. These are very interesting processors from a design point of view because what they do is they take logic and they compile it directly into hardware. And that way, what you have is completely deterministic latency. There is no operating system. There are no context switches, right? So you know exactly. And of course, for machine learning inference, this is very, very, very important, right? So these are the architectures that we have in there, okay? Now, how many of you think that data processing will run on these machines? Be honest. Raise your hand. Very few, and most of them my students. So which they have no choice. They need to believe me, right? I mean, so think again. If you will have been around at the end of the 90s, and they will have told you that we were going to build databases like the architecture that Snowflake came up with, right? You will have told them, you're nuts. We are never going to do that. This is hugely inefficient. Why do you want to have the whole engine distributed across machines and the data all over the place, and you have no schema, and there is no organization of the tables, right? I mean, and your page is not 4 kilobytes. Now you're dealing with hundreds of megabytes. You know, people will have told you this doesn't make any sense. We did it because we had to do it. Now the problem is that these are the architectures We are talking about LLMs. Instead of talking about these stupid LLMs, we have to need to talk about the hardware where LLMs is running, because this is the dominant hardware that we are going to have in the future. So maybe not these machines, but something like this is going to be what you're going to have in the cloud. If you don't read anything but SIGMOD papers, which I'm already starting to discourage you to do, you might find out the level of investment that is being made into machine learning, right? This is buying GPUs. This is not buying CPUs, right? I mean, if we are not there, very soon in the cloud, most of the computational power is going to be on GPUs. So instead of paying attention to AI, what we need to pay attention is to the thing that actually makes AI possible, which again is transformers and algorithms and all those things. I don't want to sort of take any credit away from these people, but what makes AI possible is the hardware, is the revolution that we have in hardware. And what we need to do is we really need to get into that revolution and understand it, influence, and take it to our advantage. And forget LLMs. The music is in the hardware. This is why the company that is most valuable today is NVIDIA. It's not OpenAI. They're worth a lot, but the one that is worth is the hardware company. So let's get into the hardware. Now, what is there for databases? And this is what I'm going to just take advantage also to speed up a little bit. What is there for databases? What can we do about this? Well, if I have not convinced you, let me actually resort to a much higher authority and quote Raghu, who actually has been saying this all week long, including on his talk on Sunday. Raghu has been saying that in 3 to 5 years, data analytics will run on GPUs and FPGAs. And being at Microsoft, I assume he knows what he's talking about, to the extent that anybody at Microsoft knows what they're talking about. So, sorry, this is the academic joke. It has to be made. No offense to Microsoft, right? I mean, anyway. So, but this is very important, right? Because honestly, I think this is the type of things that we ignore. This is the reality. Raghu is one of us, right? Database professor, right? In Wisconsin, right? He's telling us the world is moving to a different platform. We are not putting collectively, we are not putting enough effort into this. And the problem is that you ignore hardware at your own risk. If your research is based on doing whatever it is that you're doing on a CPU, by the time you're done with your PhD, you are history. Because in 3 to 5 years, which is the time that you have until you finish your PhD, the world is going to be on GPUs. And you come with your fancy algorithm and your fancy optimization for CPUs, and nobody gives a damn about CPUs anymore. And in fact, CPUs are being replaced with smaller and smaller CPUs. They are going to be there, but they are going to be used for just doing, some parsing and distribution and some of the high-level management and things like this. But the heavy lifting is going to be done by different type of processors. Okay? Now, why is this specialization possible? You might actually tell me, well, this has been tried before. How many of you have heard about the Gamma database machine? All right? All right, so anybody above the age of 45, 50, right, raise their hand. Everybody else has no idea. So anyway, the Gamma database machine was a project, the paper is from 1990, from Wisconsin, David DeWitt, where they actually tried to build a specialized processor for databases. Now, this is, whenever people tell me Gustavo is trying to do hardware for databases, they tell me, oh, the Gamma machine never worked, you're toast, right? Now, that was a long time ago. Now, the reason why that didn't work is because the hardware market was very, very different to what is today. At the time, we had Moore's Law, and if you built a specialized processor that takes several years to develop, by the time you were done, the processors have already become twice as fast, 4 times as fast, 8 times as fast. And then you need to come up with a new version of the chip, and then processors have moved 2, 4, 8 times, right? So a specialized processor really could not catch up with Moore's Law. This is no longer the case. Moore's Law has not disappeared, but it has slowed down. We still have more transistors, but they can actually not be used to make things faster. We're actually using them to put more accelerators. This is where if you look at Intel or AMD CPUs, they're having more and more fancy components in there, but they're not becoming faster. They are becoming far more specialized. And none of those things are being done for us, in spite of the fact that we are a multi-billion industry. Why is this the case? Well, my honest view is because we don't put enough work in actually telling the computer architects what are the things that they could put in there so that they can actually improve our industry, our research, and our algorithms. But why specialization is possible, and this is actually a very, very, very crappy rendering of one of the slides that Raghu had in his talk, but I thought it was a very nice way of presenting this. So we have gone from standalone monolithic engines, this is what we had until the turn of the century, as Philip has been presenting this morning, around 2010, around there, people started seeing that the cloud really doesn't work for databases, people started moving to cloud-native engines, Snowflake came in, and Spark came in, and Databricks, and in the meanwhile, we have a whole collection of these things. And now, recently, we moved to data lakes. Data lakes, and I'm quoting Raghu on this, is the anarchy of data. This is not just dump your data into a store, object store, and there is no access control, there is no schema, you have no indexes, they wish you good luck, and so forth. And people very quickly realized this doesn't work, so let's move to lake houses. Lake houses is an attempt to actually put some order into data lakes by adding concurrency control, consistency, access control, security, isolation, schemas, indexes, all those sort of things. And again, Raghu explained this far better than I did. Now, what I want to use this evolution is that, of course, putting specialized hardware on standalone monolithic engines that you were actually selling to people was very difficult. Why? Because you had a computer, and you had a computer, and you had a computer, and it was very difficult to tell them, well, you need to buy a computer, and you need to buy this specialized hardware, put it in there, and you need to maintain it yourself, and then you actually need to look at different versions of the operating system and the drivers and things like this. This became a nightmare. You could actually not do this. But we are no longer selling databases, standalone databases, or very few people are doing this. We have moved to the cloud. In the cloud, hardware innovation is moving extremely quickly. If you go to the systems that Amazon, Microsoft, Google have, right? I mean, Alibaba, the computers that they have in there are highly specialized. There is nothing like the standard computer that you can actually buy, right? I mean, they don't resemble at all the computers that we have in mind. And they are being highly specialized. So this is why specialization is actually possible. So now, very quickly, let me actually point out some of the possibilities that we are really not exploring in my perspective. So accelerators are here to stay. We need to do much more work on understanding these accelerators and what we can do from the query process. Not everything works, but if we don't try, we don't know. There are new processors and instruction set architectures. This is actually work that I understand is a bit more challenging because it requires understanding computer architecture, requires understanding databases, but it's also very important. If you're looking for a very promising topic for your PhD, I really encourage you to actually go in this direction. Look at computer architecture, look at what is happening in hardware, and try to adapt databases, database technology right to this new hardware. And AI, now let me talk about AI, is actually changing many things on this hardware, right? So we have new number formats and data representations. AI works with quantized data. Can we work with quantized data? Can we work with any of those number representations for databases? Can we actually use them for something that we are doing? Processors are being adapted to these new data representations, right? Can we actually use those, right? And so forth, right? So as food for thought, what is matrix multiplication what is the matrix multiplication of data processing, right? So AI was very successful in coming up with a specialized hardware because they realized that matrix multiplication was the operation that everybody needed. And they were very lucky because matrix multiplication was designed for neural networks. And it so happened that transformers also use matrix multiplication. Otherwise, they would have been deep yogurt. Because they were designing processors for neural networks, and it was not obvious that they were going to work for transformers. But if you are doing matrix multiplication, that also works for transformers, and all this hardware actually works very well. So as a challenge, what is the matrix multiplication of data processing? Okay. And all ideas for the old dog. Tova was yesterday talking about all ideas for the new dog. I want to sort of make a pitch that, of course, AI, LLMs are very important to databases. I will not recommend, like Tova was doing, to contribute to machine learning. If you want to contribute to machine learning, go to machine learning conferences and convince them of how great database techniques are. You don't need to convince us that databases are good, right? But we can actually take many of these things, and we can actually take many of the things that we have developed over the years of this core subject that we are and apply it in our context. So schema integration and database federation, Jagadish talked briefly about this. This is at the heart of data lakes and lakehouses. If you have agentic AI agents that are going to go and do different things on databases, well, go and take sagas and complex transactions and make sure that those agents can actually undo and compensate, and they actually have consistency at the end of those things, right? Query optimization, we have decades of query optimization, but this is all for CPUs. Now we need to do it for GPUs, right? So we have the possibility of this core subject that we have been developed over the many last years, right? For CPUs, for a particular context, in the most part for standalone machines, and completely revisit and redesign it, right, for this new landscape of hardware and applications and cloud that we have today, right? So this is really the best times for database systems research, right? None of the assumptions that we have our system designs, our the principles that we hold dear, right? I mean, no longer, they are not true anymore, right? What we need to do, what we have in front of us, is the challenge is reinvent data processing for the 21st century, right? And this is really the challenge that we have on top of us. So don't waste time with LLMs, don't waste time with AI. Focus on hardware, focus on what is really changing the world, and then let's try to influence that hardware. Let's try to be actors on that world by actually coming up with what is going to be the new data platform, the new core subject, right, of computer science, about data management in this world that is emerging in front of us, right? So I have a bunch of other slides that actually I'm not going to cover, just to sort of make sure that we have some time for questions, because I think what I have said is controversial enough, and what was coming afterwards is even worse. So I will stop here. And then we take questions, and if you want to hear the rest, I'm happy to chat with you during the break. All right, so thank you very much for your patience.
Thank you, Gustavo. We have about 10 plus minutes for questions, right on time. So Mohan is going to be the first flamethrower of today's.
Great to hear the talk. It's exciting to see at a personal level. He was my postdoc from 94 to 95, and how much he has evolved over the decades and become such a big deal personality and all that. So
I'm still trying to recover from that. Right?
Good luck. So in a sense, it's a chicken and egg problem that you sort of brought up. Which comes first? The hardware comes first, and then all the jokers like us are supposed to adapt to it? Or we get to figure out what needs to be done and go to the hardware guys? The way you put it now, oh, NVIDIA is doing all this stuff, you better take advantage of it. What made them do whatever they've done? Did they think carefully enough about all the world's workload, or only AI stuff, which is really the transformed version of what they originally designed the damn thing for, which was games and so on, right? Graphics, really. So why do you think they know what they are doing, and hence whatever stuff you showed is something that we should take as fait accompli and then adapt to it?
So, okay, so you described the situation correctly. My point is that what we're doing right now is that they're throwing hardware at us and then tell us figure it out, right? But we need to change this around. We need to get ahead of the game, understanding what hardware can do for us, and tell them, right? I mean, so to the extent that I can talk about it, this is one of the things that we are doing. We're now working with NVIDIA, trying to understand what relational workloads mean for GPUs. And I have no idea whether NVIDIA is going to do anything about it, because I don't know, I'm not involved in their business plans. But definitely we are trying to sort of, in an imaginary world where you develop a GPU that is focused on data analytics and not on machine learning, how that GPU should look like, right? Now, this is just my group. It's not enough, right? I mean,
Yeah.
we need many, many more people. And of course, with GPUs now, we are seeing that this is picking up, right? There are more papers, right? But definitely not enough. We need to sort of look much more on this because, as I said, the future is not on CPUs. The money is not on CPUs. The money is on GPUs and specialized accelerators.
See, there was a time when Intel came to us, to IBM, and said, oh, we are not software kind of people or applications people, middleware people or whatever. Here we are working on this byte addressable non-volatile memory. You IBMers tell us, with all your expertise in database area, how you might use the thing. Of course, later on, they even shut shop, this Optane thing, right? Are the NVIDIA guys doing similar things with not just universities, but even commercial organizations that are in the...
Yes, yes. So again, I mean, the point that I'm making is that in the past, right? I mean, when you were still young, it was very difficult to get to Intel and tell them to do anything because Intel was really the dominant force in the market.
Yeah,
and
right.
then they just give you the processors, and again, they wish you good luck. Figure it out. Here are the features. This is what I think everybody needs. It was a general purpose processor, right? They need to work for all things. This is what has changed. This is what I'm insisting, that the cloud is becoming highly specialized. People are developing, and this is very clear, people are developing specialized hardware only for particular applications, right? And NVIDIA is actually evolving the GPUs very quickly. I mean, that is one part of the fascinating part about GPUs, right, is that they come up with a model every 6 months, right? I mean, they have hardly started to sell one model, and the next one has been announced. They are evolving very, very, very quickly, right? And that is the chance that we have, because in a world in which hardware is evolving so quickly, you do have the possibility to influence that hardware.
But
right?
there is a lot of chaos. I don't want to take up too much.
We'll discuss later. Right.
Carsten?
All right, Norman. And then while we fix your microphone, we go to the next question. Norman.
We'll
In
come
the
back
right
to
queue.
Carsten. Maybe the next one.
Gustavo, thanks a lot for this wake-up call to think about hardware. So you said that in the future, in the data centers, we will have GPU-based systems, right? These GPUs are tuned for throughput, right, and not for latency. In the data management, we also have OTP workload, which is very latency sensitive, or HTAP workload, right, where you combine transaction workload and you want to have low latency access to the data for analytics. Can you share your thoughts how this part of the workload would be supported?
So again, here I'm going to take advantage of what Raghu said, because I agree with him. Transactions are a very difficult thing. So transactions in the cloud, no matter what cloud provider said, do not work because this distributed architecture introduces so much latency, right? I mean, that's not a scale. This is why now you're actually finding Oracle Excel data running in Microsoft Cloud, right? Because if you have something that is highly demanding, the distributed architecture of the cloud doesn't work. Raghu actually pointed this out. They said Lakehouse is great for all up. We will put transactions because you need consistency, but he does not believe that this is where we are going to run OLTP, right? That is another area where we need to go and figure it out. And actually, this is a very, I mean, for those of you who are old enough, right? I mean, there have been already many discussions of pushing transactions to the operating system and to the hardware and try to get support on it, right? So again, I repeat the story. This is the chance on convincing the hardware people, telling them, you know, look, if you implement this, all of a sudden, this multi-billion-dollar industry of transactions is going to become far more efficient. We're going to be able to sell more systems. We're going to be able to run more transactions, and life will be better for everybody, right? But yes, transactions is a different thing at this moment, right? I mean, everybody is focusing on all up for obvious reasons, right? I mean, Carsten, let's give it a try.
Finally, it's working. Gustavo, thanks a lot for being provocative. Let me also be provocative.
Yes.
So hardware vendors have been constantly fooling us as a database community and telling us stories about what is the next big thing, right? If you just think back, take Optane. We've wasted a generation of PhD students producing papers on Optane, and what came out is commercially irrelevant. To put it a bit on the negative side. What makes us believe any of the future hardware trends that come up are not just, again, a unicorn that is actually not existing? For GPUs, I'm quite okay. They are there, right? They dominate. But there are other things hardware vendors talk about, CXL, whatnot, right? So why and how should we differentiate between on which horse should we ride and which should we kind of skip?
So this is an excellent question. The answer is that we don't know. The hardware vendors don't know either. I mean, to be entirely honest. So there are many startups, many companies, including the large hardware vendors, coming up with different versions of hardware and see what it sticks. So again, part of the problem that I see from our community, right? I mean, is that first we don't listen. The word people saying non-volatile memory, forget Optane, right? Non-volatile memory does not really work for us, right? But still, it went on and on and on and on, and then Intel decided that they were Optane and they were taken away. This is going to happen with a lot of the hardware. I can give you a long list of hardware projects and many different companies, including the cloud providers, right? That went there, they put it there, they tried, they tested, it didn't work. Again, this is something in the past didn't happen because hardware was evolving much more slowly. Because with the level of specialization that we have today, hardware is evolving very quickly. What is important, and the reason is that why we do this dance, right? I mean, in the database community, is that we said, oh, non-volatile memory, and everybody starts non-volatile memory. We don't really think through what is the type of memory, what is the type of hardware that will be truly useful for databases. We take a concept that is given to us, and then we work with it. And then, they pull the rug under us, and then we are left hanging, right?
But often it's actually hard to judge what is end-to-end beneficial, right? And here, why do we...
We need to measure, we need to test. Today, there are great tools for doing this. There is hardware simulation, there is hardware emulation. You can actually use FPGAs like what we do. I don't sell FPGAs, by the way. I use FPGAs to actually emulate different forms of hardware and different architectures. This is actually very easy to do these days. It's not very complicated, right? My point is that, yes, there is a risk in doing this, like in any other research, otherwise we will be doing development. But if we don't have enough people trying these things, then we are going to be confronted with what Mohan was saying. The hardware people will continue throwing hardware at us and wishing us good luck, right? And then we will continue being reactive and try to catch up. Right?
Thanks a lot.
Hello. Thank you, Gustavo, for the amazing keynote. I think actually it was less controversial than the yesterday's one. So I wanted to ask, I am all for reversing kind of the power dynamic of academia versus industry. So you're saying we should have a bigger say on how hardware is designed. And my question is, how? What could we do? What could I do as a young researcher? Because of course, I can't just pick up my phone, call Jensen Huang, and tell him, hey, stop doing matrix multiplication, start doing table joins. Should we be... and I don't see anyone from...
You will be, I mean, at this point, you will be surprised.
But more to my point, I don't see anyone from Intel or NVIDIA here, right, at SIGMOD, for example.
Well, so again, I mean, this is what I'm saying. I mean, this is us as an island, right? So first, as a community, we need to open up. We really need to learn about what is happening in other areas, right? As a university, as an academic, as somebody doing research, you can do a lot of things. You can start by exploring what hardware can do for you, right? And then at a certain point, you need to switch and start asking how can I actually come up with a hardware that is useful for data processing. This is what we're doing in my group, right? I mean, so you call me a hardware guy. I'm not a hardware guy. I take hardware and I actually build different configurations, and I typically put different applications, databases, data management being one of them, but not only, and then we try to figure out what works and doesn't. And very often we figure out this doesn't work, right? I mean, so right now, I mean, I don't really want to talk too much about my work. Talk to Jonas, who is there, right? I mean, one of the things that we want to do next is we have a bunch of, over the years, we have accumulated a lot of database operators, and we want to do a very big study comparing what runs well on a CPU, what runs well on a GPU, what runs well on an FPGA, under what configuration, under what setting, and so forth, right? That's something that everybody in academia can do, and this is a lot of work. So if anybody wants to participate in this, please contact me, and we give you access. We have actually this hack cluster that you mentioned that is available for people in academia, where you have FPGAs, you have GPUs, you have CPUs, and we have a lot of infrastructure already built in there for you go and try your join. And if your join works, I guarantee you that you can call Jeff and tell him, hey, I have something for you.
But I guess what I'm missing is like this last step in the chain, right? Like how do you take this research and you've shown that some new hardware could help you? How do you actually make sure that it has an impact on what Intel or NVIDIA is doing?
So, sorry? Yeah, so just very quickly, I don't have, I'm not a special, I'm like any of you in academia, right? I have been lucky that we publish papers, not only here, we also go to systems conferences. I'm a great believer of if you are doing things in security or you are doing things in machine learning or in architecture or in networking, you go to the networking conferences or the architecture conference, you don't do it here. And then if you do that, you build credibility and companies will come to you. This is what is happening to us, right? They see our papers and they contact us and say, this is interesting, right? And again, we are not special. Companies do this all the time. You just need to sort of try to sort of get ahead of the thing and not work on this incremental thing, right? I mean, that, as I said, the database dance, right? That is not going to get the attention of anybody, right? It's people who like dancing, right? Thank you. Amol? Amol, yeah.
Thanks, Gustavo, for a great talk. As someone who is a little bit further away from this area, when I look at it, what I see is a lot of heterogeneity. That's very daunting. Right? Every chip, every GPU seems to have some different characteristic, and we see algorithms that are specialized for each one of them. And so I guess my question here is, do you see that in future, few years from now, are we going to have, like we have to live with this heterogeneity, have different operators for every type of CPU or GPU, which might be, hundreds of them maybe? Or do you see some sort of abstractions that allow us to build at one level higher up? Right.
So right now, the world is not what it used to be, right? I mean, so cloud providers are all building their own stack. And honestly, if there are cloud providers here, my apologies, they have no interest on the interoperability, right? Everybody understands this. Again, I refer to the work, and Matteo is here, and Nico is here, right? I mean, the Microsoft people, right? I mean, what they have done with their system, right, is actually build this layer of abstractions so that they don't need to fight different hardware. Velox from Meta was a library built, and if you read the introduction of Velox, that's what they say. We got fed up of having to develop a new library every time some new hardware appeared, and now we're trying to come up with something that is portable across hardware and builds this abstraction. Building these abstractions is on us, right? We understand abstractions. Computer architects don't understand abstraction, right? They understand parallelism. They understand how to make hardware fast. But their business is not abstractions. Abstractions is our business. So we need to look at these architectures. We need to understand them. We need to understand what's good for us and build this abstractions layer. And that's the research that I'm really encouraging to do here. Right? Great question.
Thank you. Keeping in mind Jagdish's point that we should not ignore pods, we have Floris.
Yes, thank you,
Floris.
Gustavo. It's always nice as a pods person to see the SIGMOD community being kind of criticized, so thank you. In name from the pods people, we really appreciate it. Now to come to my question, so suppose we invite you as a keynote speaker in 2066, right? Would you give the same talk where you replace the GPU with the QPU, quantum processing unit?
Well, so part of the thing that I'm saying is that we don't know what this is going to end, right? This is evolving very quickly. Again, and this is accelerating, right? So 20 years ago, in a database conference, you will have presented a Snowflake architecture and people will have told you you're nuts. This doesn't make any sense, right? And at the time, the cloud was evolving, but not that fast. These machines, NVL72, right, I mean, is barely out there, and they have already announced the one with the additional rack with additional processor, and they have announced the NVL144. Amazon is building this 20,000 GPU supercomputer thing, right? Things are moving very quickly. We need to get into that train. It's a train that is moving very fast, but the later we get into that train, the more behind we're going to be left, right? I mean, so there is nothing that I can do. And I apologize to you because I told you that I was going to mention pods. I have a confession to make. Nobody is perfect. My first paper that I published in databases was in pods. And my first program committees that I was in a database, it was in pods. Like working with Mohan, I'm still trying to recover from that. It's my shame. But as I said, nobody is perfect, right? I mean,
You can always come back if things don't work out for you, so.
Just a quick one. A great talk and great dancing moves. One problem you mentioned, what is our matrix multiplication? And we looked at it Snowflake, and people like to optimize hash joins and all of that, but when you look across a large workload, not a single thing was more than a few %. And that's very different than in gaming or AI or many other fields. So of course we can benefit from things like network, faster memory, maybe scratch memories or something like that. But do you think there is hope because with this setup?
It's very tough. So as I said, to the extent that I can talk about this, we're working with NVIDIA on this. They gave us a bunch of the models that they use for modeling performance on GPUs. But of course, all these models are for AI. We very quickly realized that these models do not do anything for databases because AI is matrix multiplication. Matrix multiplication is all waves of the same operation. Everything is very repetitive. And then you can actually pinpoint what are the kernels, what are the things that you speed up, and then the whole thing. So what we're finding out is that whenever you run TPCH or TPCDS, there is a huge amount of kernels, there are many things happening. But we should not give up, right? Maybe my take, and this is the way I'm thinking as a researcher, and that's the freedom of academia, is that I think we are looking at it from the wrong perspective. We are looking at it from the point of view of operators, right? So we are looking at it as hash joins, right? Is there something lower, right, in the architecture, right? Maybe on prefetching, maybe on the level of parallelism, maybe on the instructions that we have in there, right? And so forth, right? That will actually help us, right? To actually spin things up. And it might not be speeding up a join, right? And I think if we start changing the way we think, right, and get a bit closer to architecture, because it's difficult that a join will be implemented in hardware, but maybe some parts of a join, right, hashing, maybe a finite state automaton implemented in hardware, right, for stream processing and things like this, right? We already, there are papers showing that 50% of the joins are on strings. I don't remember who had this paper, right? Yeah. So strings can actually be very well supported in hardware, right? Yeah. So all of a sudden, there is something that we show hardware architects how to do this. Maybe we get this, right? But I think it requires us to change a little bit the way we think.
Yeah, cool.
We are running short of time, so maybe we'll just take one last question. I see Yanis has been waiting. I'm sorry, some of you have been also waiting longer, perhaps. But
I'll stay here, happy to discuss, yeah. Right? If you want to go for coffee, you can go. Yeah. Unless they shut down the room, we can continue doing this in a group, right? Everybody who wants coffee, go for coffee. The rest stick here with me. Yes?
So, Gustavo, I totally agree with what you suggested, that we watch the advances in hardware and adjust accordingly. But I am a little more skeptical on influencing. Influencing happens at this level by only one way: how much dollars we can deliver to NVIDIA. And this means that we have to find use cases that the next database use cases, that the next generation of hardware will turn the impossible into possible, right? So by that token, I think we have to up-level our game to basically go into cases that are harder computationally, because you cannot get the attention of NVIDIA when you want, count star versus, Google DeepMind bringing AGI.
No, I understand what you're saying. I think maybe I emphasize the processors a little too much, right? Or NVIDIA. There are a lot of things, especially in academia, right? And definitely companies are doing this, right? So you don't need to come up with a new processor architecture. You don't need to wait for NVIDIA to change the architecture of a GPU, right? What you can do is you can come up with different configurations. So I learned from Matteo. I don't know where Matteo is from Microsoft, right? If you are here, raise your hand so that people can actually ask you questions, right? They are building their own boards, right? It's not as deep as actually doing a processor, right? But they are building their own boards, combining different processors, doing different things to try different things. This is something that you can also do in academia. It's a bit more expensive, but if you get together with people, electrical engineers, you can maybe take a GPU, a small GPU, you can take an FPGA, you can take an NIC, put it on a board, and then actually build a system, right? That actually allows you to go and check whether an idea actually works, right? So yes, I understand. I'm not crazy. Moving NVIDIA, changing the business of NVIDIA is not going to happen because of the work that I do, right? But if collectively we have enough research that shows what works, what doesn't, how, over time, we will, as I said at the beginning, will become a core subject, right? I mean, that will influence these industries, right? But also research, right? And move in the direction that we need to build better systems, as opposed to constantly being a reactive mode and try to hammer what we are doing into whatever architecture they throw to us.
Thank you.
Hope that answers.
Thank you very much. I'm sorry we're quite a bit out of time, but what we will do is, since this room is available, we will honor Gustavo, and there's a small announcement, and after that, those who need to leave for the next session can leave, and if Gustavo is okay, we can continue with questions.
I'm happy to
that.
stay here, right? I mean, we can continue discussing until they kick us out, right? Okay. All right, thank you.
Excellent talk, and luckily nobody has thrown spears and other barbs in this direction. You feel free to do so after I leave the stage.
All right. So we need to move in the middle. Thank you. Okay, sure. So anybody who wants to take a picture with me, just come to the stage right afterwards, right?
With the dance.
And talk to my lawyer for the rights. All right, great. Thank you. So was it good?
Okay, before people leave, an important announcement. Today's dinner will be in 2 batches. One will be at 6:45 to 7 starting, and the other will be around 7:30, 7:45. So what we are doing is we are giving you a sticker which will be put on your badge so that you don't have to come and wait for half an hour or 45 minutes. So what I would request you to do is stop by reception anytime today, and they will give you a sticker for your badge. And that will let you know when to come. No, we'll minimize waiting. The registration, sorry, the conference registration desk, there are a couple of counters there where you can pick up the timing. Yeah, so we can, those who have questions now can come up and ask.